We'll now begin section 1.7, where we will introduce the idea of quadratic equations and talk about how to solve these equations. So let's begin with the definition. A quadratic equation in one variable, say the variable is x, is an equation that can be transformed into the form ax squared plus bx plus c is equal to 0. Your a, your b, and your c are real numbers, and a is not equal to 0. Such equations are called second-degree equations, as x is raised to the second power. So in other words, as an example, you're going to have numbers in place of the a, the b, and the c. So you might have 5x squared minus 3x plus 7 is equal to 0. So you have a 5, a negative 3, and a 7 as your a, b, and c. And your highest power in the problem is a 2. Therefore, we call it a second-degree equation. So we're going to begin this section by discussing some methods that we can use to solve quadratic equations. The first method that we use is factoring. And so we're going to look at several examples of how to solve quadratic equations by factoring. So our first example is 5x squared plus 10x is equal to 0. Now, one technique that we use when we are factoring is to factor out anything that is common to all of your terms. So if we look at the 5x squared and the 10x, we know that in terms of the number that we could factor out a 5 because 5 goes into 5 evenly and 5 also goes into 10 evenly. We could also factor out an x because both of the terms have an x variable. So if you are to take a 5x out of a 5x squared, so you want to ask yourself 5x times what would be required to make 5x squared? So you would need another x. The number is fine because we already have the 5, but we only have one x on the outside and we need a total of 2. So we'll put 1 on the inside. And then what about for your second term? 5x times what to make 10x? So the x is fine in that case, but we would need to multiply by 2 to make the 10. Now, once that is done, then you're going to take each of your two factors, so the 5x and also the x plus 2, and you're going to set those equal to 0. And you're going to solve each one for x. So in the first one, we would divide both sides by 5, giving me a solution of x is equal to 0. In the second one, we're going to subtract 2 from both sides, giving me a solution of x is equal to negative 2. So x is equal to 0 and x is equal to negative 2 are the solutions to our quadratic equation. Now, notice that in order to solve this quadratic equation, we had it set equal to 0. That is important as we move forward. We need to be sure that each time we go to solve a quadratic equation, it is set equal to 0. So note in part B, s squared plus 9 is equal to 6s. This equation is not set equal to 0. And so that would need to be our first step. Let's take this 6s and subtract it off of both sides of the equation. In other words, let's move it to the left. So that will give me s squared minus 6s plus 9 is equal to 0. Now, I note that there's nothing common to all three terms, so I'm not going to be able to factor it in the same way that we factored part A. And so if there's nothing common to your terms that can be pulled out, your next approach is to see if you can get it to factor into a double set of parentheses. Now, remembering your FOIL method, remember that what you put here and here in the first locations needs to make s squared. So that will have to be an s and an s. And what you put in the last two positions needs to multiply together to give you 9. So we can do 9 times 1 or we can do 3 times 3. But we need to select a pair that would somehow combine to make 6. So 9 plus 1 is 10 and 9 minus 1 is 8. So that's probably not going to be a great choice. But 3 plus 3 is 6. And so I think I'm going to go with that. Now once that's done, then you can identify your signs. The 9 needs to be positive, which means they either both need to be plus, positive 3 times positive 3 makes 9, or they both need to be negative. And since we're aiming for a negative 6, let's let both of the terms be negative. And so if we set these equal to 0, and note that you do have a duplication here, solving it for s, we're going to add 3 to both sides, and so we get s is equal to 3, and obviously we would get the same thing on the other term. This is called a double root, or it's called a solution that has a multiplicity of 2, because as we solve this second factor, we get exactly the same thing. So our answer is s is equal to 3, but we might say to ourselves that that's a double root, or that it has a multiplicity of 2. And our third example is also a little different because it has fractions. So we have the issue of it not being set equal to 0, which we're going to have to deal with, and we also have the fractions. Remember that the easiest way to get rid of the fractions is to take your least common multiple of your denominator and multiply all of your terms by that. So in this case, it's just going to be 2. And so we're going to be multiplying each term by 2. 2 times x squared would just be 2x squared. When we multiply 2 times our second term, which is 5x over 2, the 2's cancel, leaving me 5x. And then on the right-hand side, we have 3 halves times 2. Again, the 2's cancel, leaving me a 3. Now, let's go ahead and subtract that 3 off so that everything moves to the left-hand side, and we have 2x squared plus 5x minus 3 is equal to 0. We check and see if anything can be factored out, but again, in this case, nothing is going to be common to all 3 terms. And so we'll move on, saying to ourselves that hopefully we'll be able to factor it with a double set of parentheses. So remember, first times first has to make 2x squared, which means that one of those has to be 2x and one of them has to be 1x, because that's the only way to make 2 is 2 times 1, and the only way to make x squared is x times x. Now, whatever we put in the last 2 positions have to multiply together to give you 3. So it is either 1 and 3 or 3 and 1. And so what I'm going to do is I'm going to pick 1 and 3, and then I'm going to check it real quick to make sure that I have it right. If I don't, I'll go back and make it 3 and 1. All right, so let's take a look. When we FOIL this out, and we'll get signs on there in just a minute, but when we do the outside terms, 2x times 3 is 6x. And the inside terms, we have 1x. And so my question is it possible for 6 and 1 to combine to make 5? And yes, it can if the 6 is positive and the 1 is negative, right? Because we want to combine to make a positive 5x. So how do we make the 6 positive? That came from the 2 and the 3, so this one needs to be plus. And how do we make this 1x negative? We need a subtraction here. All right, so again, as you're factoring, you want to check this using the FOIL method to make sure that you have your numbers in the right place and make sure your signs are in the correct place. Then we're going to take each one of these and set it equal to 0. So 2x minus 1 is equal to 0. We'll add 1 to both sides. It's going to give me 2x is equal to 1. And then divide both sides by 2. X is equal to 1/2 as one solution. On x plus 3 is equal to 0, we're going to subtract the 3. Gives me x is equal to negative 3 as a second solution. So that is how we can solve quadratic equations by factoring. And factoring would be our first method for solving. Our second method for solving is to solve the quadratic equation by taking a square root. And so we have a couple of examples here so that you can see how this works. Our first example is 2x plus 3 squared is equal to 8. And so we're saying that we can take the square root, and in hopes that will help us solve the quadratic equation. So I am going to, on part A, take the square root of both sides of the equation. So when I take the square root of something that's squared, it kind of cancels each other out on the left, and I'm left with 2x plus 3. When I take the square root of 8, remember that taking the square root of a number produces a positive or a negative answer. That 8 could be written as 2 times 4. The square root of the 2, I cannot take the square root of 2, so I'm going to leave the 2 underneath. I can take the square root of the 4, and the square root of 4 is equal to 2, so there's going to be a 2 that's going to come out to the front as well there. So we're going to end up with something like this, plus or minus 2 on the square root of 2. Now we still have to solve for x, so our next step is going to be to subtract 3 from both sides. So that's going to give me 2x is equal to negative 3 plus or minus 2 on the square root of 2. These are not like terms, so they can't really be combined. And then my last step is going to be to divide by 2. And so x is going to equal negative 3 plus or minus 2 on the square root of 2 over 2. And that is two solutions because one of them will have the plus in between and one of them will have the negative in between. All right, so let's go ahead and look at part B. So the only difference in part B is that the squared portion of the problem is not by itself, and it really does need to be before we try to take a square root. So my first thing on this one, the problem reads the quantity x minus 5 squared plus 4 is equal to 0. I'm going to subtract 4 from both sides. And so that's going to give me x minus 5 squared is equal to negative 4. All right, and then we're going to take the square root of both sides. The square root of x minus 5 squared is just going to be x minus 5. Remember that when you take the square root of a number, you have to consider the positive and the negative. When you take the square root of a negative 1, which is what's sitting in front of that 4, remember that you get an I. And you take the square root of 4, you get a 2. All right, now I'm going to flip those around so it looks a little better. So I've got 2i coming out of that. And then finally, solving for x, we're going to add 5 to both sides. And so our answer will look like x is equal to 5 plus or minus 2i. And again, that is two solutions because we have 5 plus 2i and we have 5 minus 2i.